We're continuing our review. This is a chapter 26 item where we're supposed to draw a phosphatidylinositol. Hey, if you're supposed to draw a phosphatidyl anything, you're always going to draw the phosphate ester like this. Attached to carbon number 1 of glycerol. Here's glycerol. The glycerol backbone. We're putting an inositol on there. And it says inositol is cyclohexane 1, 2, 3, 4, 5, 6 hexol. So every carbon of cyclohexane has an alcohol. Didn't know that, huh? It's a natural molecule. And it tells us we want axials and equatorials. So yeah, Dr. Whitaker's forcing you to draw a chair. So I'm pretty sure yours is an inositol too. I'm just going to try to take away some stress right now. You'll see other exams. It's a serine here sometimes, and it's another group on there sometimes. Yours will be an inositol. I'll just change which ones I want equatorial, which one's axial. So it says carbon number 1 is attached to the phosphate ester. Inositol should be drawn in chair form with the phosphate ester carbon 1 equatorial. So I'm going to erase this bond, and it's going to be attached to an equatorial position. Now, if I draw a cyclohexane like this, remember 2 parallel lines? From the inside corners, 2 more parallel lines, then hook them up at the end. And this looks like it would be equatorial right there. Oh, we locked out one of our students. If you could put that garbage can there, that would help. Call that 1. How do I know it's equatorial? Because it's slightly up. You don't have to draw the axial on this, but there it is, straight down, following this carbon angle right here. Down angle, straight down axial. Don't need any of that. Let's see, equatorials on C3, 4, and 5. 3 is like this. 4 is like this, parallel to the, not the adjacent bond, but the adjacent to the adjacent. What do I mean by adjacent to the adjacent? This is parallel to this. Okay, that's what I meant by adjacent to the adjacent. Other alcohols are axial, so 2 and 6 are axial. We'll put those in purple. Straight up. Hey, they're both straight up because the carbon angles are straight up. Look, carbon angle straight up. Carbon angle straight up. Pointing up, I should say. There you go. 5 is an equatorial, right here. Yeah. And we need a lauric acid, which I looked up on the handout, and it's a 12-carbon fatty acid that's saturated. My dad called those Saturday fats. 2, 4, 6, 8, 10, 12. It's on the handout, right? And EPA, I need your help. Please make sure we're going in the right direction here. What's after the carbonyl? I think you're reading it backwards. How many CH2s after the carbonyl in EPA? 2? CH2 once, CH2 twice, then a parenthesis. What's the first thing you read going that direction in the parenthesis? Is it the double bond or the CH2? The first thing, if you're reading from the carbonyl direction. We don't have our handout. I'm gonna just go steal a peek at this handout right here. EPA carbonyl. So it starts inside the parentheses with a CH2, and then it goes double bond. So parenthesis number 1, CH2 up to double bond. Parenthesis number, how many of these? 5. CH2 up to parentheses. And yellow. Oh, yellow's dangerous. That's 4. That's 3. Orange. This is a very healthful fatty acid, all these cis double bonds. That's 5. And then what's after that? CH2, CH3? 2 CH2s, then a CH3. Go purple. Oh, no. We're not reading that direction.
Yes,
CH2. Yeah, we covered all this carbonyl, the CH2, CH2, then parentheses 1, 2, 3, 4, 5. I'm going from right to left on your handout. What's in the far left? CH2, CH3. There we go. Omega-3. Yeah, I know things are wrong if EPA doesn't end up being an omega-3. Omega-1, 2, 3. Very helpful. Now we're going to do some circling, some judicious circling, and you can save yourself a heck of a lot of time on the next part. Looks like I'm not circling the carbonyl. I got to remember that. So R is going to be bonded to OH after hydrolysis. That's the inositol. Now in 6 molar sulfuric acid, you better believe phosphoric acid is fully protonated. Fully protonated. And these acids are fully protonated, and glycerol is fully protonated. Glycerol is glycerol. And carboxylic acid 1. R prime, R double prime goes to a blue carbonyl with an O that now has an H. And R double prime, purple carbonyl, black O. Actually, the black O is not black. Doesn't matter. There we go. 5 molecules. 5 molecules. 1, 2, 3, 4, 5. Done. Hydrolysis. That's what happens during digestion, by the way. Your body does hydrolysis of molecules. All right. Now we had, I believe the next one was for, it's going to be a multi-activity question because it's a protein determination. And I'm told it was from last Wednesday's notes. That's where I'm going to go get it. I better stop the video though. Uh-oh, we might have an issue. Okay. Share screen. Back over here. The second one? Yes, I didn't have the proper label. It probably, if it's one little mistake, I might forgive it, but technically, that's bad labeling, wasn't it? Thank you. All right, so we fixed it. We saved it. We're stopping it.